Nice to see everyone. My name is Ivan Wallis. I'm a global architect with Venafi. My focus is on really securing the software supply chain for a lot of our customers. So I help out with our CodeSign Protect product, helping our customers on that journey, right, of securing the software supply chain in the enterprise. Really excited to be here to talk about one of our latest research reports. Organizations that are struggling to secure AI generated and an open source code. The first thing that I kind of was excited to look into was the concern that developers are increasingly reliant on open source building blocks, but often do not question whether these can be trusted. This rings home just as myself being an open source developer and a maintainer of a number of Venafi projects in GitHub. These are definitely some concerns, right? So it'll be important to leverage tools to automatically check for vulnerabilities, right? In dependencies included in any of the AI generated code, right? Whether it's Copilot, whether it's ChatGPT or Grok, wherever you are getting your potential source code, it's going to be important to build this into your daily life as a developer. At the end of the day, you'll still need human review and testing, and always, of course, rely on experienced developers to review and test AI generated code for security vulnerabilities prior to deployment. It's also going to be important that AI models are trained on data sets that emphasize secure coding practices. The other one that gained my attention was that security teams need to be empowered with the capability to meet developer speed, right? Automation is going to be very important, right? So this is a concern. As we've seen across the industry, there are issues, right? Trusting open source libraries, such as recently with the XC-Utils open source library. Essentially, it was compromised over time. So most, if not all, software relies on third-party dependencies, right? Third-party libraries. And so you can imagine the impact beyond traditional software development and how we apply this to AI-generated code and software, and even into the realm of ML model software. So another area going through the report was this kind of widespread concern that developers may be taking security shortcuts. Happens, right? With the way that enterprises are continuing to scale and they're kind of trying to develop as quickly as possible. The security pros have concerns around just the speed of development. 35% fear gaps in communication between developers and security teams. And I think this gap will lead to oversights in security. And I think this really needs to be addressed going forward. In working with a lot of my customers and prospects, especially when it comes to protecting software, is that typically I hear developers aren't putting in the proper controls to protect their signing identities or their keys and certificates. And at the same time, security teams are quickly attempting to put a lot of these policies in place, and there's a really big difference between kind of creating and enforcing these security policies. Right, so it's a constant tug of war. Developers want to be able to move quickly. They might not understand the implications of these additional controls around software supply chain security, and that leads me to another one of the top developer security concerns: is 36% of developers leave their keys to the kingdom, right? The keys and certificates, and these are exposed on potentially local devices, not a lot of proper controls over them. And so unfortunately, we run into this a lot when talking to customers, and really to help remediate these issues and move towards security access control over keys and certificates. Right, these are things that we advise when we talk with our customers that are moving in that direction. They want to mature that whole process. Many organizations still have either none or minimal controls over protecting these code signing identities, especially the private keys. If we think of production, 28% of developers will ship vulnerable code into production. That's a big concern, right? When we look at LLM application lifecycle, they could be as we've seen with traditional development, right, compromised by vulnerable components or services that are leading to security attacks. So using third-party data sets, pre-trained models, and plugins, right? They can add potential vulnerabilities. So we think of plugins as additional components that leverage maybe third-party data, right? Third-party services to help the AI produce the most accurate results, right? So we think of examples like plugin design. They lack parameter separation. They lack authorization. Configurations can override settings. And if we look at helping our customer implement preventative controls, we want to include enforcing type checks, right? Use validation layers. We want to ensure authorized identities via short-lived, also known as ephemeral, OAuth tokens or API keys are being used. These are going to be these are the top developer security concerns. And of course, right, here are some ways that we can start to mitigate them and improve security. Reading through the report, there's one part that really stood out, right? Open source often helps developers move more quickly than securely. And that's a great example. And it's absolutely true, right? With open source often bridging the functionality gap in many enterprise software, it is a default behavior amongst developers. Unfortunately, there are plenty of examples. I just talked a little bit about the XC utilities, the compression decompression library that was compromised over time. There's plenty of other examples where vulnerabilities were introduced in different ways. In summary, for this section, it's really just pointing that out and demonstrating that the industry is aware of this, and we're constantly working to catch up and really working on what we've seen with a number of industry approaches, whether they're NIST documents, whether they're OWASP, SANS. Really, everything's kind of focusing now around software supply chain security, and so that's also going to be very important in the realm of kind of AI generated code and how it fits in with open source. And to that point, right, 90% of security professionals trust implicitly code in open source libraries. 43% saying, sure, complete trust. If it's on GitHub, GitLab, why not? It's been vetted, there's maintainers, many of them are backed by larger software vendors. So this is really a good place to kind of talk a bit about SBOMs and software bill of materials as a way to start to bridge that gap, right? And if we're going to be trusting open source, we need to be able to have kind of a trusted dependency map of trusted software components, right? And once again, XC Utils is a good example of open source projects. I would say that's probably more of the recent supply chain software attack. Essentially rely on free software, in this case for very important parts of software where you have to be able to compress and decompress data. So these vulnerabilities can be particularly dangerous because it allows attackers, right, to execute arbitrary code, cause denial of service. You can imagine as we now shift over to AI generated code that we have to be able to trust open source libraries and dependencies. At the same time, right, 75% say it's going to be impossible to verify the security of every line of open source code. And I agree, right? Generating and maintaining these software bill of materials, the SBOMs, I think is a great start. And to put some guardrails around this is probably might feel a little overwhelming. But there's definitely some good, positive trends in the industry. There's actually some good open source projects. One, Hopper, which is HOPPR, which is developed by Lockheed Martin, that allow organizations to collect, process, and bundle digital assets as you transfer software between multiple production environments. So I think that's going to be key moving forward, right, to really bridge the gap between what is developed internally versus what trusted software is brought in from the internet. As mentioned, I do development work on the side and I do incorporate some AI generated code, but I can imagine, right, obviously you scale this to an enterprise, and so it's widely used, but it's also not easily controlled. A point here, I think that was interesting and makes sense. AI is now being used to develop code, and it's being used at a fairly quick pace. Absolutely, adoption is increasing exponentially. And I do want to reference kind of the OWASP top 10 for LLM applications, because they mention a lot of these areas that we need to be really focused on, right? Areas to be cautious. Some of them, prompt injection, insecure output handling, one that maybe we've seen more in the news or some experiences that previous versions of AI generated code had, poisoning the training data. And of course, because they rely on open source and software supply chain, we have to look at the potential for vulnerabilities. Another area that, is going to be important, 83% say developers use AI to help generate code. I'm surprised it's not a little bit higher than that. This increasing reliance on AI systems can lead to human oversight because AI is going to generate this code and it's trusted, right? It makes it harder to intervene when AI systems fail or are compromised, right? LLMs can provide misleading info without validation. I think a very key point is that it's very possible that these LLMs may suggest insecure code in software. Now, kind of thinking of preventative measures may include the need to regularly review the LLM outputs, consistency checks, verify it against trusted sources, right? Training data, trusted open source libraries, trusted data, and then going back to helping mature the developer, the secure software development lifecycle for developers, right? You need to establish secure code guidelines to prevent the introduction of potential vulnerabilities. 72% say they have no choice but to allow developers to use AI. And because the technology is so new, guardrails, there's not a lot of them, right? Safeguards are very, very few. We need to look at that, right? One of these safeguards is around reliability and accuracy. So AI models may produce outputs that developers do not anticipate. Where does that lead, right? It leads to unintended behavior in software applications. And I also think with anybody being able to get information from ChatGPT or any of these systems, there's a potential for ownership and attribution. AI-generated code or design artifacts can raise questions about IP ownership and proper attribution. And that, if you kind of see where this is going, potential legal disputes. It's really about understanding, right, the speed of AI-generated code is being widely used, but at the same time, industry is catching up, right? Not a lot of safeguards, not a lot of guardrails. So these are going to be some interesting points to consider. Think of, once again, AI generated code and the difficult part of really enforcing and creating some of these security controls. So 63% think it's impossible to govern the safe use of AI in their organization as they don't have visibility into where it's being used, right? And I think this is a key point with my customers, right? I ask, how are you protecting your signing keys? And in many cases, their teams are probably doing something, but security teams have very little visibility into what's being used. We need, visibility into the tooling, dependencies, any software components, any technology that's being used to develop the code, to validate it, and then to release it. I think overall, when we transpose this over to AI, it's really about kind of establishing, an AI governance framework. We define some of the ethical principles, implement risk management practices, ensure data privacy and security, right? Create a compliance and audit mechanism. And I would say that this is just the starting point. The final point in this area is 59% of security teams say they lose sleep thinking about some of the security implications of AI developed code. We're trying to prevent over-reliance. Developers might become overly dependent on AI. This potentially leads to a lack of manual review or critical thinking, and potentially resulting in lower quality software. So in my opinion, a continuous reliance on AI for coding or design tasks might lead to a degradation of these necessary, developer skills. So another area of the report I found very interesting. Once again, AI generated code continues to raise, security concerns. 34% of threat actors poisoning AI models to potentially insert malicious code. So to prevent such scenarios, we need software supply chain verification. We need to verify external data sources and libraries. So we have to ensure the data legitimacy, since, a very real threat is that potential for malicious actors to manipulate the model with their own biased data. 33% say establishing and verifying the provenance of code will become more difficult. And that's a valid concern, right? Because, we're producing so much code and there's a potential for over-reliance on training data and third-party software. So we have to reel back and just become much more secure. There's areas that we can take a look at, right? areas that will help them secure software supply chain development and deployment. But there's a framework out there called SALSA, or supply chain layers for software artifacts. And that provides a very good checklist of standards and controls, really to prevent tampering, improving the integrity, and being able to secure those packages so that you can roll them out securely within not only your environment, but maybe potentially your customers' environments. So it's going to be about getting safe enough, being resilient as possible at any link in the chain. So thank you for listening, and for more insights, please download the research report today. And thank you very much.